Pick any whole number you like. If it is even, cut it in half. If it is odd, triple it and add 1. Repeat, and watch the number tumble downward. A child can do this, yet no one can prove it. Let's try it with the number 6. 6 is even, so we have it to 3. 3 is odd, so we get 10. 10 halves to 5, then 5 leaps to 16. 16, 8, 4, 2, and finally 1. Here's the plan for this little rule. First, a rule simple enough for a child. Have the even numbers, triple the odd ones and add 1. Second, every number falls down to 1. Repeat the rule and you always crash to 1. Third, a wild climb before the fall. Numbers can leap up high before collapsing. Fourth, a tree that grows from 1. Run it backward and all numbers branch from 1. Finally, simple to state, impossible to prove. 90 years on, nobody can prove it. Now let's look closely at the 2 steps. Take your number and check if it is even. Even numbers get cut neatly in half. Odd numbers get tripled, then bumped up by 1. That is the entire rule, with nothing hidden. This pairing of steps has a nickname. People call it the 3n plus 1 problem. Here the n just means your starting number. Yet from these 2 steps, long journeys grow. Some numbers settle fast, others wander for ages. Now for the strange part everyone notices. Whatever number you pick, it seems to fall. Sooner or later it drops to 1. Then 1 turns to 4, 2, and back to 1. It locks into that tiny loop forever. People have tested this with computers. Every number up to 21 digits obeys. Billions of cases, all falling to 1. Not one of them has ever escaped. Still, that is only checking, not real proof. Time for the wild part of the journey. The drop to 1 is rarely a straight line. Numbers can shoot up far higher first. A small start can climb into the thousands. Then, eventually, it always tumbles back down. Plot the journey and it looks almost alive. The path jumps up and down without warning. No pattern says how high it will climb. Short numbers can take hundreds of steps. The chaos always ends at the same place. Now let's run the whole thing backward. Start at 1 and undo the rule instead. Each number can be reached from others. Trace every path and they join into a tree. Every number hangs somewhere on that tree. This tree branches out without end. Thinner and thinner twigs reach every number. It curls and spreads like a living coral. No artist drew it, only the rule did. Order and chaos share the same branches. So surely such a simple rule is solved? It was first posed in 1937. A mathematician named Collatz wrote it down. Almost 90 years later, it still stands open. No one has proved every number reaches 1. The greatest minds have all tried and failed. One famous mathematician offered cash for an answer. He admitted the math might not be ready. Whole careers have bounced off this little rule. It is a dangerous problem to fall for. The closest anyone has come is striking. In 2019, a top mathematician got very close. He showed almost every number must fall. But almost every is not the same as all. That last gap is where the mystery lives. So what does this little rule leave us? 2 baby steps, repeated, beat the whole world. Every number we try still falls to 1. We just cannot prove the ones untried. The simplest question can be the hardest.